Hi, my name is Muhammad Azhim Hasib bin Mazlan. My matrix number is 01DGU21F1045.
Hi, my name is Muhammad Haikal bin Nozaini. I'm from DGU 1B. My metric number is 01DGU21F1048.
Hello, my name is Muhammad Amrul Aizat bin Muhammad Noor and my metric number is 01DGU 21F100 F1066.
Hello, my name is Muhammad Zulfadli bin Rosli. My metric number 01DGU21F1044.
Introduction to Trigonometry. Trigonometry, as the name might suggest, is all about triangle. More specifically, trigonometry is about right-angled triangle, where one of the internal angle is 90 degrees. Trigonometry is a system that helps us to work out missing or unknown side leg of angle in a triangle. There is more about triangle on our page on polygon. Should you need to brush up on the basic before you read further here. How to use trigonometry in engineering. Trigonometry is not just a subject to be studied in a classroom with no real-world practical application. Engineers of various types use the fundamental of trigonometry to build structural systems, design bridges, and solve scientific problems. Trigonometry means the study of the triangle. It is further used to find the angle of a triangle when the leg of the side are known, or finding the leg of two sides when the angle and one of the side leg are known. Once all of a measurement of the triangle structure are known, the engineer can begin building and define the scope of the project he or she is undertaking. The following are the steps to understanding and using trigonometry in the field of engineering.
Trigonometry in Engineering. Determine what field of engineering trigonometry will be used. In addition, use sound reasoning to build your business case for using trigonometry. Define your project plans and anticipated milestone. The following are the most important questions you must ask and define in the early stage of your project development schedule. What is your project scope and vision? How many resources do you need? How long will this project take from start to completion? How will you validate your measurement and the structural integrity of your work? Taking measurement and calculating the dimension of what you intend to build and or create. For example, while studying civil engineering, you will have to calculate the force distribution for different structures, such as truss bridge. The engineer must also figure out what the angle between the beams in a bridge must be and how long they must be. Build your tool or system according the measurement. You should also create a specification sheet for your design for future reference. Validate the structure integrity of your work. Does it meet all of your initial requirements? Have you had it inspected?
Used in civil engineering. Very form of math at one point in time to do her job. Algebra is used on a daily basis, and many engineers will have to deal with differential equations, statistics, and calculus occasionally. A good portion of civil engineers time is not spent doing math, but when the time comes, civil engineers have to be very comfortable with all the forms of math, especially those that deal with physics. Civil engineers use math equations that are derived from symmetry on a daily basis. Symmetry equations are used to measure the strength of material, and engineers must use the equation to select the right material for a project. Civil engineers use trigonometry often when surveying a structure. Surveying deals with length as well as various angles of structure. Physics take on a huge role in a civil engineering job. Physics equations are applied to all the angles of an engineering problem to make sure the structure being created is going to function the way it must. When a bridge is being designed, physics is used to figure out how large the supporting piers should be, as well as how thick the steel columns of right need to be and how many of them should be installed. Physics equations are typically use algebra, calculus, or trigonometry. Basic math skills such as accounting and statistics must be utilized during the planning phase of any project. Figuring out the financial side of a project is an important part of civil engineer's job, and he must figure out how much is how much a project is going to cost its investor.
Okay, let's continue to the question that have trigonometry in it. The diagram below show a model of a plane with its wing piece. Ali want to calculate the perimeter and wing area of the plane to make a package on it. What is the perimeter and wing area of the aircraft? Here the answer that we can see. Firstly, we must search for the BD length where we can use a cos law to get the length where BD equals to 19.83 cm. After that, we must search the ADB angle where 127 minus 86.6 equal to 40.4 degrees. After that, we can search for AB length where AB per sin 40.4 degrees equals to 19.83 per sin 44 equals to AB equals to 18.5. After that, we must search for the ABD angle where 180 minus 44 and minus 44.4, and we will get ABD equals to 95.6 degree. With the ABD angle, we can search for the AD length where AD per since 95.6 equals to 19.83 per since 44, and we will get AD equals to 28.44. The perimeter, we can just add all the AB length and BC, CD and DA length, and we will get 122 cm. For the area, we can search the BDC triangle first using 1 per 2 multiplied by 39.59 multiplied by 35.5 and multiply again with since 30, and we will get 351.36 cm per meter. For the area of ABD, we will use the same calculation and we'll get 185.36 cm over by 2, and the total area we just add BDC total area and ABD, and we will get 533.72 cm power by 2.